Okay, so let's add some probability back into the mix here. Those two definitely don't go together. Those two drugs do they? Okay, so probability. So the idea is probability, we know that you take the number of ways an event can occur over the number of possible outcomes. So the probability of getting a heads when tossing a coin is 1 out of 2 because there's one head and there are 2 possible outcomes, heads or tails. Okay, so we're using that idea, but now we're going to use our fundamental counting principle. So we're going to do all the things we've just been doing. So here we go. Let's run into an example and let's go to Paris. So given the 5 letters Paris, if the 5 letters are written down in a random order, so, we've got this idea of these letters we're writing down. We don't know what order, if it's going to write Paris or, whatever order it is, SIRAP. Now, what's the probability that a word formed will start with P and end with an S? So it feels like we just now have 2 problems where we had 1 before. So the first is to see what's the total number of, variations we could have here. Well, we could put any of the 5 letters in the first block, and then there are 4 letters left, 3, 2, 1. So I'm going to walk you through and say, well, that's 5 factorial, right? 5 times 4 times 3 times 2 times 1, and 120. Now, I think you're definitely going to be punching that into your calculator. We're not working with factorials enough to kind of get a sense and go, oh, 5 factorial is 120. I know that off by heart. So calculator, and you get there are 120 total possible words that can be formed. Okay, now what we need to look at, what's the probability that the word will start with a P and end with an S? So now we can look at a specific example and say, if that's a P and that is an S, I'm going to rub out these and say, now we look at the probability, so the number of P, 3 letters, S. How many are there? So now we can say, well, let's look at these middle blocks. We know there's only one way of doing that and one way of doing that. We're left with 3 letters that we need to do. So we could choose any of the 3 for the first block, any of the remaining 2, any of the remaining 1. So there are 3 factorial ways of writing a word that goes P, summing, S. Okay, 3 factorial is 6. So therefore, our probability of writing a word P summing S is going to be, well, there's 6 words that could be like that out of 120 that could be formed altogether. Into your calculator it goes, and what do you get as a decimal? Okay, clearly you know how to work your calculator though, so 0.05, just to give us a bit of a pause there. Okay, now let's do the same idea with Paris and say, what's the probability that 2 vowels will be next to each other? So let's just jot down, the total number of words is still 120. We don't have to rework that out. We know that there are 120 possible words. Now we need to see that the 2 vowels need to be next to each other. So I'm just going to write, I've got A and I are 2 vowels, and then we've got P, R, and S, just to see there are 5 letters. We're going to be putting this into our 5 blocks, 1, 2, 3, 4, 5. And for this now we need to think, okay, how do we do this again? What we did was in fact, maybe let me just ask you, do you kind of think, how are we going to see how many ways we can have the 2 vowels next to each other? Jot down your idea, actually page back through the examples. Okay, so that's probably a good thing. Hopefully you've put some ideas down there, and of course I will see when you filled it in. So the way that we did this was that we saw how many ways could we put those vowels. We could put them over there, that's 1 way, 2 ways, 3 ways, 4 ways. So there are 4 possible ways to put the 2 vowels next to each other. Then we see how many different ways are there to have that within the group. So you could either have AI or you could have IA. So there are two different ways we could order within the group. And then finally, we need to look at how many ways are there of placing all the other letters. Well, there's the P, R, and S. So let's just say that those A and I went over there. There are 3 blocks that are left. So there are 3 factorial ways. Let's say that we're looking those. You could put any of the 3 in there, say any of the other 2, and there's only 1 left. So there are 3 factorial ways of placing all the other letters. So therefore, if we multiply all of that out, we get 48. So there are 48 ways of doing that, and therefore our probability of this event happening, and I'm not going to actually write what that is, that the 2 vowels are next to each other, well, the probability is 48 over 120, which gives us 0,4. Okay, so that's our probability for that. Let's keep going with our one. So let's stick with this idea of probabilities and do a second one here. We'll do the very last example in the next video. So suppose that a number plate is formed. We've had our number plates before using 3 letters of the alphabet, excluding vowels and Q, and any 3 digits. So we've got our number plate. Let's just picture what's going on. 1, 2, 3. Those are letters of the alphabet. And then we've got our 3 digits. So how many letters are there if we exclude vowels and Q? Well, we've got 26 in the alphabet minus those 6 give us 20 different letters. And then for our digits, we've got 0 to 9. So that gives us 10 different digits. Okay, so when we look at how many there are in total, because we're going to need that, how are you going to work out how many combinations there are in total? Well, we've got, 20 different options here, because there could be anything of all our letters. We've got 20 options here, we've got 20 options here, and we've got 10 different digits, 10 different digits, 10 different digits. So in other words, we've got 20 to the 3 times 10 to the 3. Okay, and into the calculator it goes, and we get 8 million. Okay, so they're the total different number plates we could have in this scenario. Now what we're going to see is, because we're dealing with probability, is basically part 2 of the question. How many work like this? So I'm going to rub these out so we can use our same digits here and say, well, what we want to see is it starts with a B and it ends with a 5. Okay, so how are we going to work out how many options there are that start with a B and end with a 5? Well, there's only one way of doing that and one way of doing that. We're left with these here. Well, this could be any of the 20 letters. This could be any of the 20 letters. This could be any of the 10 digits, and this could be any of the 10 digits. So for our, start B, end 5, that was well written. We've got 1 times 20 times 20 times 10 times 10 times 1. So we've got 1 times 20 times 20 times 10 times 10 times 1 gives us our answer. Now, maybe just a quick thing, because I'm wary of, using too much shorthand here, because we want to show our reasoning. So just so that you can show your working along the way, make sure you got like the 1, 20, 20, 10, 10, the timesing and that along the way, so we can see our working out. So just something we haven't really spoken much about. Okay, so that's what we got there, 20 squared times 10 squared, which is 20 times 10 squared, 200 squared. So we've got 40,000 different combinations that have that. So therefore, to wrap it up, our probability of that event happening is, well, 40,000 over 8 million. And my calculator, when I did this just a second ago, gave me 0,05. Okay, so 2 more with our number plates. Same idea. So we've still got a total of 8 million. We don't have to work that out again. So that's quite nice about having these sub-questions. Don't you think? Yeah. So we've got, I don't know, I was just like, woof, was kind of a question set. So has exactly 1B. So now life gets a bit more interesting. So I'm still going to draw my 1, 2, 3, 4, 5, 6. Now in this case, if there's exactly 1B, we need to think of 3 different scenarios. So I'm going to draw this. We could have our B. Really should change to those lines. Oh, hallelujah. So we've got 3 different things. That, or that, or that. We could have our B here. We could have our B here. Or we could have our B here. But I can't think of a nice, quicker, neater way to do this. Just to go, you could have your B there. And then exactly 1B. So how many different options are there to put in here? Well, there are 20 altogether. There are 20 letters. But there are only 19 that could go in there because we can't choose a B. So the same, there's still 19. We can't choose a B. All the others are up for grabs, but aren't those. And we could still choose any of the 10 digits. So that's what that one's going to look like. Or, again, we've got 19 options for each of those and 10 different options for these. So we're going to, one option for that, times, 19 times, only one option there, the B, times. And finally, the B's over there, only one option to do that, but there are 19 different letters that could go in there, 19 there, 10, times. Now, if we're dealing with OR, what are we going to do with each of these 3 things here? Well, we're going to add them. Remember, always add. So we're going to go that thing plus that thing over there. So each of these was whatever it is, and enter the calculator, pop it in the calculator just to check what you get and, see whatever matches up with what I got. Well, I got 1,083,000 different options. So when we want to work out our probability, let's write that in another color. Our probability of having exactly 1B is, get out the way, is those options there. No, I've got too many zeros. 1,083. No, that was right. What's about you, right? Over the 8 million. And into the calculator goes, and I get 0,135375. Okay, so that's our probability, kind of 13.5%. I've just left all the decimal places. Obviously, be guided whatever the question says. So last one. Well, not the last one. There's still more examples in the next video, but last one for this one. So we've got our number plate. I always want to read the thing. Suppose that a number plate every time. So we've still got our number plate. There's still a total of 8 million different options over here. Okay. Now, what we want to see in this scenario is if we've got 1, 2, 3, 4, 5, 6, it has at least 1 5. So we're not interested in these, right? We could have any of the 20 letters, any of the 20 letters, any of the 20 letters. Now, if we start going with our OR thinking, now I just want to stop that for a second to go, so we could have a 5 over here. That would be one option, right? And then we could have anything over here. Or we could have 5 and a 5. Or we could have 5, 5, 5. Or we could have not a 5 there, but a 5 there. It feels like there are a lot of different things. So there's going to be a much quicker way. What do you think our idea is going to be? Because we see this at least. Same when we did it with our tree diagrams before, and we saw some sort of at least, and we thought about, now hang on a second, if we wanted to see everything, and that's kind of our at least, and there was one route we're not taking. So what's our strategy? I've kind of given away quite a lot there. Hopefully that's enough to get you thinking of, what's your strategy going to be on this question? Well, because we got this idea of at least, it means that we got all the options except for one option. The only thing that we don't want is to have exactly one, to have no 5s, right? So I was going to say 1 5. So the only option that we're not interested in is if we've got no 5s. So in that case, let's say that we're going to look at that and say, well, if we have no 5s, we can choose from any of the 9 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we're not going to choose 5. So therefore, that can be anything but 5 times anything but 5 times anything but 5. And that's going to be the exact opposite of what we want. Which means that if we multiply all of these out, we get 5,832,000. So that's the number of options we have with no 5s at all. So I'm just going to put here no 5s and move out the way again. No 5s. Okay. So the probability of getting no 5s is that number, 5,832,000 over 8 million. So therefore, the probability of getting at least 1 5 is 1 minus that. Okay, so hopefully that's ringing some bells, and I get 0,271, give or take. So again, just to finish this off, kind of feeling on that. Things are starting to come together now, hopefully a little bit. But yeah, so the probabilities, and you're kind of thinking through all the strategies. Yeah, we had the 4 different ways of seating this, 2 within that, 3 factorial ways of doing it. So those ideas are now coming into 1 and drawing on ideas like, oh, that at least we went 1 minus. So just maybe a quick jot down of how you're feeling before you get into the last video. Okay, well, that is that. I reckon we say